Hi everyone, welcome back. Today we're going to be looking at standard 6.G.A.1. Find the area of right triangles, other triangles, special quadrilaterals, and polygons by composing into rectangles or decomposing into triangles and other shapes. Apply these techniques in the context of solving real-world and mathematical problems. So we'll be focusing on calculating the area of a parallelogram. Area is the amount of space inside the boundary of a flat two-dimensional object. Area is going to be measured in squared units. The amount of carpet needed to cover a floor is one example of how we would use area. A parallelogram is a flat shape as shown here with four sides where opposite sides are parallel. So this would be parallel to this, and this side here will be parallel to this side here. To find the area of a parallelogram, we multiply the base. So here would be our base. And we multiply that by the height, which needs to be perpendicular to the base, meaning that it forms a 90-degree angle. So that would be our height, that would be the base. So for this example, we would multiply the 9 times the 7 to calculate our area. Well, the formula of area equals base times height is very similar to that of the rectangle. And here is why. If I were to cut off this portion of my parallelogram, okay, if you notice there's a triangle over here to the side, and this over here would actually create a trapezoid, I can move this piece over to this side. So I can literally take this and put it over here as shown in image number 3. And when I put that together, it will make a rectangle. So a parallelogram can be transformed by cutting off one of its sides against its perpendicular height, reattaching that to the other side, and making it into a rectangle. So that is the reason why the formula is the same as calculating the area of a rectangle. What is the area of the parallelogram? So first, let's go ahead and write our formula. A equals base times height, where my base would be my 7, and my height needs to be perpendicular to the base. So wherever you see this 90-degree angle will be our height. So A is equal to 7 times 2. The area here is 14 yards squared because area is always in units squared. Let's try another example. Again, A equals base times height, where our base here would be 8 and our height is the 3. Not to be confused with this leg over here. This is not perpendicular to the base. Therefore, we would not use the 5 in this example. However, if we were calculating the perimeter, then we know that that side is 5. So is that side. If this is 8, so is this one. And then we can use that information to calculate the perimeter. So here we find that our area is 24 inches squared. Here is an example involving decimal. The process is the same. So our base is 0.8. Our height is 0.6. So we now need to draw on our knowledge of multiplying decimals. 6 times 8 is 48. And then there are 2 places, so I have to move 1, 2 in my answer. So here the area is 0.48 inches squared. These examples are asking us to work backwards. So we're given the area and it's asking us to either calculate the height in the first example or the base in the second example. So let's go ahead and write out our formula. A equals base times height, where the area here is 12. So I'm going to substitute that in for A. My base is 6 and my height is the letter H. So now I have 12 is equal to 6H, and I can use my understanding of solving algebraic equations to divide both sides by 6 and find that my height is 2. Now, because we're not calculating the area, this would be 2 miles. okay, because we already have our area here, which is measured in square miles. Now for the next example, we'll do the same. A equals base times height. So we're told here that the area is 48. We don't know the base and the height is 8. So I can go ahead and rewrite this as 8b. And I'll use inverse operation, divide both sides by 8, and find that b is equal to 6. So here, my final answer is not going to be inches squared, but 6 inches. Thank you for watching and have a great day.